Okay, yeah. So this was, so I was in the same internship project, and in the process of finding all these challenges and encountering questions that we thought like, oh, this would be interesting to look at, but we have all of this complexity in the data yet. Maybe we can try to build some sort of prototype for a simpler data set. And funnily enough, we ended up also with the NHS cancer time targets, so there will be some overlap between the two projects. Okay, so we basically looked at like, okay, are there simple things that we could explore as tools to make the complexity in data and data analysis and data sets in general more transparent and more engaging to the reader? And the first thing that we want to propose here is agency. And so there have been a bunch of approaches to kind of like communicate, well, to the reader that this is fun and that he should engage with the data and should click on things and then see how the plots change, things like that. So like interactive graphics were pretty popular for a while, but from my perspective at least, and I think there was also a few like at least blog posts on this, is that the people that engage with this like super overwhelming, all the options, click through it and then see the values for yourself, are really already the people that are into this kind of thing. So for a layman, I guess it's really hard to really engage with it. So here what I instead want to propose is that it's basically more like a choose your own adventure kind of experience. So we've seen that, for example, in the EU subsidy data, there's lots of questions that you need to answer before you can even dream about really plotting something or answering any meaningful question. So for example, match funding, should this be in the table? I mean, the value that we get from the European Union is efficiently zero, right? So I mean, the first thing you would think about is just filter it out, right? But it kind of depends on what you're interested in. Like even something trivial, like I just want to count how many projects are there, then suddenly this is a meaningful data point. But also for like the much more intricate kind of like background, maybe there is actually monetary value attached to this, but I don't know at this point. So this is, for example, a question, or let's say, do I count the projects at their postcode level where the money went to, or do I try to find out, well, is it really about that, or is it about where does the money end up? Is it more project-based? It's like the postcode of like where people at the end spend the money, kind of the thing that I'm looking at. And the idea here is like, if we give the readers the options to choose along the path individually without already constraining them in any sort of narrative or like, oh, here's what we found out, click on 3 things and look at the graphs, maybe we can engage them more. And the idea here would be like, well, then suddenly it's their choices that are at stake, right? They decided at some point, maybe randomly, that they really think that match funding should not be in there. If then, as a result of that, they end up in some situation where then they have to, explain themselves, the idea would be they feel more attached to this sort of hypothesis because they incorporated it into their narrative. And an additional thing here is like this changes kind of the way that you approach a data set from in-depth kind of drilling down of aggregate levels of variables, let's say, to more looking in like a more pluralistic kind of like, so what sorts of aggregations are there in the data? What sorts of variables are potential candidates for a narrative in the story? Yeah. Okay, the second thing is that we want to propose here is, so a lot of questions, so James alluded to this, is like, there are often counterfactual questions in data sets in general. And then, I mean, we always shy away as researchers and say like, yeah, just correlation, no causation. But then every other sentence in the paper says basically, oh, it's causation. So you can shy away from that, or you can do some sort of regression analysis, and then you can be very precise and like try to do it in a clean way and try to explain all the assumptions that went into it, and then be very careful about how to interpret your results. But I feel like an alternative to this is people really, like, it doesn't take much for people to do predictions under certain characteristics. Like we see this, for example, now in Brexit, like everybody has an opinion of what would happen, and we can't even really talk about what the assumptions are, but people are very, like, it's very easy to say like what they will expect, if things will be fine or not. And this has two characteristics. Like, so if at the core of my story there is some sort of prediction, or if I want to do some sort of model, I want to communicate some sort of model or some sort of directionality in my data, instead of going this very intricate, complicated path of explaining all the assumptions that I took, then taking you on board, then showing you my results, and then also teaching you about like how careful you have to be to really use this result, why don't we play around with what a model, like a predictive model, is at its core, which is basically if I pick like from a bunch of variables, whatever that is, I should be able to say something about like the target that I want to predict, right? So why don't we just let people pick whatever they think in this data set that they think is relevant for the target, and then we just let them try to predict it implicitly. And maybe they get a feeling through this process of, first of all, how hard it is, how difficult it is to pick variables, and then if we have some sort of normative model, then we could compare their results basically to what our fancy statistical model found out, basically. So yeah, so here the idea is take a step back, basically, let people play basically at the core what, in this case, prediction is, instead of giving them like a stats 101 class before you talk about your one application of it. And the final one, and I think this does not need much more in background here, is we often forget like about the local perspective of our stories. And actually, like the tools that we have nowadays, even though there's complexity with postcodes and so, but it's relatively simple to show, if the data allows it, to show your region, to show the impact of a more general nationwide story at your local level. Okay, so we created a demo. So just in context, this was the last 2 weeks basically of the internship. So it's all a bit rough around the edges.
Yeah, so just to put into context what Pablo has been talking about, we took on the challenge of trying to determine how successful the NHS is at delivering cancer targets for waiting times. So this is similar to what the guys at the BBC alluded to in their visualization, but we try to tackle it on a more on a more local perspective, and looking at the finer details on trying to identify the predictors or factors that may contribute to why some NHS trusts aren't reaching the targets. So this all is comes from the cancer reform strategy back in 2007, where they decided that they wanted to aim for cancer patients to be seen at least within 62 days for the first cancer treatment. And the government also set a target to at least achieve it 85% of the times. But the issue here is that if you look at an article from Cancer Research UK last year, was that for the last 4 years, the government and NHS trusts in England in particular weren't achieving these targets. And there was a kind of discussion around why this was the case, and there seems to be a lot of unknowns around why, in fact, NHS trusts weren't achieving these targets, and there was a bit of speculation around the fact that this is due to the lack of resources and a continued strain on the NHS, for example, lack of funding, understaffing, and it could be also a mix of differences between different cancers, so more extreme cancers or more aggressive cancers require more assessments on how to target the treatment. And so there could be differences between different cancers rather than aggregating it all together. So after giving the context to the user has the option of determining different target times that they want to compare it to. So for example, England actually has different target time, has different targets for waiting times compared to Scotland and Wales. So in the UK we have about 85%, but in England, in Scotland and Wales, who are actually better at achieving these targets, it's at 95%. So as the user, you can see how your local NHS trust is performing based on the England target, or you can even compare it to the target set in Scotland and Wales, or you can set what you think the target should be. So if you just start off with the England's, make comparisons against England's 85% target, we can compare the NHS trust and see how it performs against that. And then also in terms of what I was speaking about earlier on, we can also allow the user to think about what is the most sensible way to compare different NHS trusts. So whether we should be aggregating all cancer types, or whether it's actually more sensible to look at waiting time targets in terms of the different cancer types, because you'd expect waiting times to differ depending on what kind of cancer you have. So it's not as simple as aggregating everything together, because then that loses some of the data and information around what may be causing the lack of the NHS Trust's ability to achieve the wait time targets. So we'll just go basic and just aggregate all the cancer types. And then the next step that we'd expect the user to do is actually, rather than give them a set of reasons on what we think might be causing the issue, we allow the user to pick amongst several factors on what they think might be factors that contribute to the NHS Trust's inability to achieve these targets. So we can choose amongst these available predictors that we collected from open NHS data and try to combine them in one unified database that the user can manipulate and explore to try and see if they can guess why their NHS Trust or NHS Trust in general in England can't achieve these wait time targets. So does anyone want to pick maybe 3 factors that they think might contribute? So here we've just listed different factors. So you have staff. SHMI index is a mortality indicator based on whether hospitals achieve their not achieve, but whether they don't exceed the expected mortality that they expect in the NHS Trust. So that's an index that is standardized across the UK. And number of patients treated in that hospital, patients admitted, administration staff, management staff, financial performance. Anyone want to pick a couple?
Like predictors in the sense of correlated with?
No, so we're talking about predictors in the sense what the user thinks are predictors. So what they can use as summaries, and then based on these factors, they can use to predict whether determine whether the NHS Trust.
So this is just like, it takes a table of data basically, and the only thing you constrain on is what is the target, like that's fixed. But then, I mean, of course there's some sort of filtering and making it a bit nicer and pick sensible names. But other than that, like all the data you have basically is like all the columns that are not the target are dumped in there basically. And you say like, well, I mean, part of the point is here, like if you pick something that is not correlated at all, or which is like correlated with another predictor, then, well, you will have trouble later on predicting. But yeah.
This is predictor in the sense of
Potential predictor.
If you knew it, you might be able to figure out the other thing. Not predictor in the sense of causal link between predictor and right.
Well, it might be a predictor that's not really predictive.
The predictor is really just a column name.
Yeah.
Well. Okay, I think James wants to pick something.
I want to pick anything that refers to sort of general performance of hospitals.
That's a good strategy.
So you could do financial, whether they financially performed as expected.
Yeah. I don't know. How about admin support for doctors, nurses, and midwives?
Yep.
Yeah.
You can pick one more if you want.
I get another one.
Yeah. You can pick as many as you like. You can even select all of them if you want, but it gives the user the opportunity to pick what they think.
Don't pick all of them.
Yeah, don't pick all of them.
So let's have financial deficit then.
Oh, very good.
Okay, we'll just go with these 2 for now. So what allows the user to look at the actual data for their NHS Trust. So here we have the University Hospital of Leicester, and we compare it to the national average. So then we didn't want to give the actual figure, we want to put it in context. So yeah, here we have it much higher than average, the admin and support staff, and they are in financial deficit. So do you think it's on target or off target compared to the 85%?
I have no opinion.
You have to choose.
You have to choose.
Swipe left or swipe right.
Yeah. You don't know.
Well, they go opposite directions. So I have no opinion.
You can't. You need to have one. Or do you think you can't? You picked your wrong predictors.
Well, I think I picked the right predictors, but these are going opposite directions in this particular example, so I can't determine.
So in this case, you'd think about what has more of an effect then. What do you think is more important out of financial deficit?
No, what's the prior?
He just isn't brave enough to make a guess. I think it's down.
Okay, we'll go not on target.
Oh, we got the good one. Did we get the?
Thomas is saying down.
Okay.
Yeah, layout is a bit broken.
Oh wait, so it's Birmingham. Right, so this would be
Birmingham.
so on my view this would be a good place, so I think it's on target, yes.
Okay. On target? Off target? Yeah.
On target? On target.
We've got on target.
Our survey says. On target. We seem to be prioritising financial deficit here. On target. Don't know.
It's Cambridge. I don't know. So just trying to help.
On target. Give me someone in deficit. There you go.
There
Not
you
on target.
Okay.
On target.
Okay. So yeah, the aim of this is to allow the user to actually think about it for themselves and try and think about it deeper rather than be presented with a summary statistic and then not actually think about on a deeper level what might contribute to it. So here we have a summary of whether their assumptions, their predetermined assumptions was correct in terms of what the data presents itself with. And this is basically, I think, as far as we got with the prototype. But what we aimed to have was that at the end of this, then have some kind of article that follows this, where it explains actually the reasons why your guesses might have been, well, not correct, or why most of the times the factors that you selected actually had nothing to do whether hospital or NHS trust achieved the target or not. And I think in this case, just to give you a bit of background of how far I got into actually building a model to try and determine the actual factors that contributed to the lack in achieving waiting time targets. The problem with this is that with the data that is published by the government and the NHS is so aggregated, so there's a lack of information about how doctors move between different hospitals and NHS trusts. So the system of the NHS isn't as simple as it is, and it's very complicated. And in that Cancer Research UK article, they actually mentioned that this was actually being assessed by the health authorities since last year, but over a year and a half later, we've still seen no report that's come across. And something like this, even if there is a lack of model at the end of it, we can at least make an attempt to explain why we can't predict, why we can't identify the factors that are associated with the inability to achieve these waiting time targets. And I think in the news especially, we don't tend to report this kind of information, so kind of a failure to identify the actual predictors. And being able to report these at the end of these interactive explorations allow the user to actually learn, or the public to learn about why it's so difficult, why these issues are so complex. So for example, with the polling data, a lot of people will just look at the final figure and say, and then just lose a lot of trust in the actual model itself, rather than looking deeper into, for example, uncertainty that aren't reported, and the model assumptions, maybe because we think they're more complex and we don't try to simplify it through these interactives. And I think it's an issue that we should try and attend to by creating these kind of visualizations. And I don't know if you want to...
No, I mean, just one thing to add here. Like, as soon as several people use this, we can kind of feed back the data into the system, right? Like, you can suggest new variables in your aggregations to the table that is behind it, basically. And you could also, like, you get some sort of demographics about your readers, and so to speak. So you will find out that people think that whatever bath is amazing and at delivering on NHS times, something like that. I don't know how to do this. You have to switch. Oh no, you're not a Mac user either. Yeah. Perfect. Okay, so this is just like a few things. Like, so as I said, this is pretty rough around the edges, and kind of funny that we took this data set to to get rid of a lot of the problems that we had, but then at the end, like, we got very similar problems in a way, right? Like, where's the doctor? Is he really in that hospital, or is he traveling around and is actually in all of these hospitals? And, you know, like, wards and regional boundaries in the UK are pretty messy, I guess, you know. So yeah, there's a lot of things here potentially that we might be able to do with this, but it kind of like also rests on like finding a story that really wants to delve into this deeper. Yeah.
That's about it.
Any questions?
I don't know if this is a question, so I apologize in advance. Like, it feels like, just thinking about what I've heard today, it feels like when you read about people who've done cool stuff with data, I get the sneaking suspicion that they got lucky. So there's a lot of people who happen to have data sets, and they're sort of having a look. And some of those people happen to have data sets that let them say cool things. And often we don't. And it feels like perhaps what's missing from the subject of data science is the subject of, okay, actually I have a question. I don't care what data set's available. How do I get the data I need to answer that question? Rather than sort of, oh, here is some data. What can I answer with that data? ... question mark. So, no.
Yeah, yeah, so I think, well, I don't know, I'm going to speak from a statistician's point of view, and I think that's what's missing in data science as well, because as a statistician, we don't tend to look into data without a question and just try to generate a hypothesis just by looking at the data. So I do think, I echo that as well. I think it is important to have a question beforehand, and that way we can extract more meaningful information out of data that we might want to collect, rather than getting a big data set and not having a clue about what we want to present from that data. And I think that's why we end up with having so much data just stored in, terabytes of data, but we don't know what to do with it because we don't have a question. And rather than getting the data and then trying to think of a question, I do think it is also important to generate that question or hypothesis first and then go look for the data, which is probably available because of the amount of information we store nowadays.
But like, I totally agree, but like, to add on that is also, I think we underestimate as humans like how much context information or real world information we need to wrangle facts or whatever, measurements, into something that we then represent in a data table. Like what you're doing in your project is really cool, but like this first step where I say like, what is a postcode? Is this really the unit that I want to use? And then given that I choose this, there's, you know, like then I have constraints all the way down. Like, I mean, I can do certain things or not. Like even like what a distance measure, like all of these things, right, go into it. And yeah, I totally agree. I think often we talk like, there's this table, and now the magic algorithm spits out the answers to all of my questions, and we move on. Like, so this is somehow trying to get into this direction of like, well, let's ask questions and let's talk about what are answers actually, what are even the kind of constituents of this question. Like, what does it mean if I ask this question? How does it phrase my problem?
One more.
Hi, thank you. I think it's a really great project. I'm interested in where you'd hope this to be hosted. Would you look for it to be on the NHS website? Kind of how you hope to find users if it's kind of finished and in an ideal world done?
From my perspective, I think it fits quite nicely into Thomas' Gamma project actually. Because, so right now, it's quite flexible in the sense that you can write your article in some sort of markdown with a few extra niceties, and then you can plug in your data CSV, and I pretend that I infer the values of the columns and things like that. But I don't feel like, I mean, this is extra work, of course, but I feel like it would really neatly fit in there, actually, like to phrase like data transformations and do this sort of analysis. I I don't know, like I have never worked with the NHS. I don't think that they would be very keen on this sort of thing.
If anyone has interesting questions where this sort of visualization might fit, then come talk to us, and it might be hosted on your website. One more, and then we'll have a lunch break.
Hi guys, that was great. I could see with the problem that you were trying to answer earlier, particularly with the EU funding, and then getting data from the European Social Fund, and looking at who the provider was and whether the provider was registered in, say, southeast of the UK, but the money spent in northwest. And I could see what you put together for the NHS, if you had probably had more time and probably better data, that you would like to have done something like that, so that you can say, well, you've got this amount of funding in this period here, in 2016. We gave it to southeast of the UK, but you're actually spending it northwest. I mean, why? And actually posing that question and using those great insights that you put together for that.
Yeah, so initially we did set out to do something like this for the EU data, but obviously we couldn't do it at the same time because we had other questions or other problems to kind of attend to. So what we ended up doing was, at the same time as trying to explore those issues, we thought we'd come up with ideas as well on eventually, when we do have that EU data, we could apply it into this context, but then just to build the tool in the first place, you need a context. Yeah. So this is initially why we alluded to using the NHS cancer waiting times as an illustration, and then how we could apply the EU data set in this example. So yeah, that would be the kind of end goal to using this kind of interactive.
All right, so thanks again.